In this video, we are going to look at some examples of dividing rational expressions. Just like the way we divide two fractions, p over q divided by r over s, we keep the first fraction as it is, change the division sign to multiplication, and flip the fraction on the right-hand side, or flip the second fraction. And then it becomes a multiplication problem. So again, rewrite the problem as a product of first expression and reciprocal of the second, and then follow the steps for multiplying the rational expressions that we just saw several examples. Let's look at our first example. We'll start with the easier ones and then bump it up a little. Okay, 7x squared over 6 divided by x over 2y. So first step, I'm going to rewrite it as a division instead of a division problem, a multiplication problem. Now cancel out the common factors between numerator and denominator, and this leaves me with 7xy divided by 3. Right, example number 2, we're going to change it to a division. Instead of division problem, we're going to change division sign into multiplication and flip the fraction on the right hand side. Now it is time to go ahead and proceed with this multiplication problem where we factor every single expression and cancel out the common factors. So numerator, I have two numbers, multiply to give me 10, add up to give me negative 11 and negative 1 and negative 10, divide them with a 2x and 2x. So simplifies to x minus 5, and then 2x minus 1, GCF, pull out a 5 from the denominator of the first fraction, and then we have x minus 5 times 10 over 2 times 2x minus 1, because the GCF of 2 from denominator of second fraction. Let's go ahead and cancel out the common factors that we can here. 2x minus 1 and 2x minus 1, x minus 5 and x minus 5. Looks like everything canceled, so we're dividing the same thing with itself, and that is going to equal 1. Everything in the numerator and denominator canceled. It is not recommended to go ahead and distribute 10 in here and distribute these two parentheses. That would make factoring much harder. It's recommended to factor and then cancel the common factors before you proceed with multiplying the numerators together and denominators together. Example number 3. So first step is to rewrite this problem as a multiplication problem with flipping the second fraction, 9x minus 12. Now we are going to go ahead and factor every single expression here. So 3 times 8 is 24, negative 10, negative 6, and negative 4 divided by a 3x and 3x. So 3x minus 4 times x minus 2, x minus 2 times 21 over 3 gets pulled out, 3x minus 4. Let's cancel out all the common factors between numerator and denominator. 7 times 3 is 21, and 21 is also in the numerator. Oh, again, everything canceled between numerator and denominator, so we're just left with 1. All the factors canceled, and that's all we're left with, just a 1. Okay, and the previous example also looks like all the factors. 5 times 2, 10, yeah, and 10, yep, that's a 1. All right, next example, number 4, we have, all right, x squared minus 16. So here, we do have multiplication and division as well. Remember, the PEMDAS says do from left to right, whatever comes first. So we can do multiplication and division starting from left to right. So we can go ahead and do multiplication first and then take care of the division, because multiplication comes first from left to right. So x plus 4 times x minus 4, when I factor x squared minus 16, x plus 6, x minus 6, x plus 6, x minus 2, and 3 times 4 is 12, 13, and two numbers that multiply to give me 12, add up to give me 13 are 12 and 1, 3x and 3x. 3x plus 1 and x plus 4. And now we can change the division into multiplication and flip the very last fraction. Okay, and there's nothing to factor, which is good, which is nice. Nothing really there to factor. Let's cancel out all the common factors. We have x plus 4 in the numerator and denominator. We got x plus 6 in the numerator and denominator. And that's all. But look at this, x minus 6 and 6 minus x. So if I pull out a negative 1 from 6 minus x, I can write it as x minus 6. And I do have x minus 6 in the denominator as well. 3x plus 1 and another 3x plus 1. Okay, let's go ahead and cancel the x minus 6 and x minus 6. And lastly, we are left with x minus 4 times x minus 2 and 3x plus 1 times 3x plus 1. Now, if you really prefer, you can go ahead and there's a small mistake over here. For this one, it is going to be 4 here, x minus 4. Please fix it. This is going to be x minus 4. This is going to be x minus 4. If you prefer, you can FOIL these out. You can FOIL them out if you prefer, but there's no need to FOIL. Now, you can leave your answer as x minus 4 squared and 3x plus 1 squared. So it's always good to multiply the factors back and check and make sure they work, because in this expression we were thinking about two numbers that multiply to give you negative 24, add up to give you positive 2. So the numbers are positive 6 and negative 4. Okay, so just make that correction, fix it, and that's all we're left with. Again, you can FOIL these if you want, or there's no need to FOIL them. Let's check out our next example. There's 2 try me problems. I'm going to have you pause the video. Go ahead and try these on your own and come back and check with me. Three x minus 2. The bottom denominator for the first fraction, negative 24. 12 times 2 is negative 24, and 5. 8 and 3. Seems like 8 and 3 would work. My first number is 12. Now, when I simplify, 4x minus 1. And we can divide top and bottom with the 4 here. Numerator and denominator both with a 4. And then we'll be left with 3x plus 2. Okay, 8 and negative 3. 3x plus 2. Awesome. Change the division into multiplication, and I'm going to be flipping the right-hand sided fraction, and I'm going to be writing it in the factored form. So 8 times 1 is 8, negative 6, negative 4, negative 2. Divide them with the 8x and 8x. 4x minus 1, and then 2x minus 1. That would be 8x squared minus 4x minus 2x is negative 6x. Okay, that is correct. 4x squared minus 1 is difference of squares. 2x plus 1, 2x minus 1. Now let's cancel all the common factors between numerator and denominator. 2x plus 1, 2x plus 1 is gone. 4x minus 1 and 4x minus 1 is gone. 2x minus 1 and 2x minus 1 is gone. All we are left with is 3x minus 2 and 3x plus 2. And that's it for number 1 try me problem. For number 2 try me problem, let's see if there's any GCF between 36 n squared minus